Hi everyone, welcome to my A-Level Biology Extended lecture series. In this lesson, we will explore excess post-exercise oxygen consumption, which is known as EPOC or EPOC. Let's get started. So EPOC, historically known as oxygen debt, refer to the increased rate of oxygen intake following strenuous activity. Is required to restore the body to its resting state by addressing the oxygen deficit. At rest, nearly all the body's ATP demands are met through aerobic respiration, which require oxygen. So what is oxygen deficit? So at the onset of exercise or when exercise intensity increases, the actual oxygen supply is lower than the volume needed to support aerobic respiration in muscle cells. So this occurs because the body requires time to adjust its cardiovascular and respiratory system to efficiently supply the utilized oxygen. So therefore, when we start at rest, when we start our exercise, you can see that our breathing rate increases, our heart rate increases. That is the body physiological changes that allow us to adapt to address these oxygen demands. So, however, this takes time to increase the heart rate for the muscle to enhance oxygen extraction. So as a result, ATP synthesis by aerobic respiration is not fast enough to meet the immediate energy demands of the muscle cell. So to compensate, muscle cell rely on anaerobic energy system, which including glycolysis, where we have learned in the previous lesson, which produce ATP without oxygen through substrate-linked phosphorylation. Creatine phosphate system, where creatine phosphate is hydrolyzed to release phosphate group, provides energy to synthesize ATP from ADP. So let us look at steady state exercise. So when oxygen supply to muscle cells becomes sufficient, ATP can be generated primarily through aerobic respiration. So most body cells can maintain oxygen level high enough for normal mitochondrial function, even though during high intensity exercise. Let us look at this diagram, okay, or this graph to show the oxygen demand as well as the oxygen supply. So at rest, okay, so you can see that this is the oxygen demand, okay, and this oxygen demand can be met by the oxygen supplies. So during this period of time, the cells carry out, aerobic respiration. However, when there is a start of the mild to moderate exercise, you can see that the oxygen demand is at this level, which cannot be met by the oxygen supply. So therefore, in order to increase the oxygen supply, the cells carry out some changes. For example, and in terms of the respiratory system as well as the cardiovascular system, we can see that there is an increase in the heart rate as well as the breathing rate. Okay, but this takes time. Okay, so cells have to carry out anaerobic respiration, and this period of time is known as oxygen deficit. So basically, there is amount of oxygen needed but cannot be met by the oxygen supply. However, due to the changes in the body physiological system, so the cells actually manage to gain the supply to meet the demand. So at this period of time is known as the steady state. So during this steady state, you can see that the oxygen demands, okay, met by the oxygen supplies. So the cells actually carry out aerobic respiration. So where is the anaerobic respiration? From the start to the steady state. So during this period of time, we have what we known as the oxygen deficit. So when there's a stop of this mild to moderate exercise, the oxygen demand actually dropped to this level. Okay. However, the oxygen consumption still remain high, and this is to address the oxygen deficit. So this period of time is known as EPOC, known as excess post-exercise oxygen consumption, formerly known as oxygen debt. So this occurred during recovery period. So however, during strenuous exercise, the oxygen demand may exceed the maximum rate at which oxygen can be delivered to and absorbed by the tissues. So at steady state exercise, the rate of ATP synthesis while aerobic respiration may still be insufficient to meet the high energy demands of the muscle cell. So therefore, anaerobic respiration continue to provide additional ATP until strenuous activity stop. So as lactate accumulates in the muscle, it causes a drop in the pH, making muscle more acidic. So this leads to the muscle fatigue and reduce the contractile efficiency. So the muscle become weaker and more prone to cramping. So let us look at this diagram again. So as we know that during at rest, okay, so oxygen supply meets the demands of the cells during at rest. But when there is a start of the strenuous activity, this is the oxygen demand, but the oxygen supply is low. No matter how the cells carry out the body carry out the physiological changes, in this case, increase the breathing rate as well as increase the heart rate. No matter how hard we try, we won't be able to meet the demand. Can you see that? The supply of the oxygen is lower than the demand. So basically, during this entire period of time, anaerobic respiration take place. So this period of time, okay, so you can see that no matter how the volume O2 maximum that can be achieved is still lower than the demand. So this period of time is known as oxygen deficit. So when we stop this extraneous activity, the oxygen demand dropped to the at rest level. But during this period of time, you can see that the oxygen consumption still remain high. So basically, after the activity, we still breathe in, our heart rate still high, our breathing rate still high, because we want to address this oxygen deficit by having what we know as the excess post-exercise oxygen consumption, known as EPOC during the recovery period. Okay, so because in this case, oxygen deficit take more and a longer period of time, therefore we need a more or even longer period of times to gain back the recovery. Okay? So EPOC and recovery. So after exercise, oxygen consumption does not immediately return to the resting level. So EPOC represents the total volume of oxygen consumed above resting level during the recovery period. So during recovery, oxygen is used in the processes that restore the body to its resting state, including replenish back the ATP creatine phosphate. So previously, creatine phosphate, okay, hydrolysis of creatine phosphate releases energy for the formation of ATP. So now we need to reform back creatine phosphate. And as well as this oxygen consumption, the extra oxygen consumption is to replenish back the oxygen stored in the hemoglobin as well as myoglobin in the muscle cell, and also to remove the accumulated lactic acids from the muscle cell, either by the converting it into the glycogen and restore it, or oxidize it back to CO2 and H2O, the water molecule. So the term oxygen debt is now considered outdated, but however, in our syllabus, we still use the term oxygen debt. Now, the reason here is because EPOC is not only used to repay the oxygen deficit, but also support other metabolic processes, which is unrelated to the oxygen deficit. So other factor, okay, unrelated to the oxygen deficit that contribute to the elevated oxygen consumption during recovery periods include increase the tissue temperature, the Q10 effect, which actually enhance the metabolism in the heart and the muscle, as well as a high level of the circulating catecholamines, the adrenaline and noradrenalines from the adrenal glands, which actually increase the oxygen consumption, but these are not related to the oxygen deficit. So with that, we have come to the end of this extended lesson. I hope you found these lessons helpful. If you have any questions, feel free to leave them in the comment section. See you in the next lesson. Have a great day.